Hello, in this video, I will explain to you on how to find all the branch currents I1 through I6 using mesh analysis or mesh current method. So the goal is to find out I1 through I6, I1 until I6. And we need to use mesh current method. Mesh current method. Okay, let's do it one by one. The first step that we need to do is to draw all the loops, right? Draw all the loops. Okay, we have 3 loops, I think. Let's name this loop here as IA. Okay, and also this loop here maybe as IB. And then this loop here as IC. So we have 3 loops, IA, IB, and IC. All of them are unknown, right? Because we don't have any current source. And then the second step that we need to do is to do KVL for all unknown loops. For all unknown loops. Okay, we have 3 unknown loops. All of them are unknown, right? We have IA, IB, and IC. Let's start with IA first. So I need to do KVL at loop IA. KVL at loop IA. Okay, and what does KVL say? KVL said that the sum of the voltage in a loop will equal to 0. That is KVL, not KCL. The Kirchhoff voltage law, not current law. Okay, and let's start with this 220 volt here, and here the current flowing clockwise. So here it will flowing from the negative terminal. So our sign will be negative here, and we already have voltage here, which is 220. Good. Now let's move on to this 2 ohm resistor. So I'll have plus 2. And the only loop current that pass through 2 ohm resistor is IA, right? So here I will multiply it by IA. Good. And now let's move on to this 12 ohm resistor. But then another current flowing, right? So I will have IA going down and IB going up. But here we are working on IA. So IA always came first. So I will have IA here, 12 IA. But then IB flowing to the opposite direction. So I will have IA minus IB. Good. And now the last component here, this 4 ohm resistor. Similarly, I will have 4. And the first current that we need to multiply is IA. But then here IC is flowing to the opposite direction, right? IA is flowing to the left and IC is flowing to the right. So I'll have IA minus IC. Okay, all of that will equal to 0. Good. Now let's do some math here. IA came from 3 terms, 2 plus 12 plus 4. I will have 16 plus 2. That will be 18, right? 18 IA. And then minus IB. IB only comes from this place. So we will have minus 12 IB. And then I will have minus 4 IC. And let's move this 220 to the right hand side. I will have 220 here. Good. Let's save this as equation number 1. And that is our first KVL. Okay. Now maybe clean up the slide a bit, right? Okay. Now we have saved the equation from IA. Let's move on to this loop here. So I need to do KVL at loop IB. KVL at loop IB. Okay, we can do KVL again. The sum of the voltage in a loop will equal to 0. let's start from this 12 ohm resistor. So I'll have 12. Here IB came first because we are working on IB. But then we have IA flowing to the opposite direction. IB flowing up, IA flowing down. So I'll have minus IA here. And then we will have 48 ohm here. So I'll have 48. And the only current that passed through it, the only loop current that passed through it is IB. So we will have IB here. And then we will have 24 there. So I'll have 24. And again, because we are working on IB, so IB came first. And here IC is flowing to the opposite direction. So minus IC. All of that will equal to 0. And then we will have IA here multiplied by 12. So I'll have minus 12 IA. Okay, and then we will have 12 plus 48, that will be 60. 60 plus 24, that will be 84. And that is IB. And then we will have minus 24 here and IC. All of that will equal to 0. Okay, and this is equation number 2. Probably let's put it here like before. And we need to do one more KVL at IC. Okay, now let's do another KVL, but this time at IC. KVL at IC. Okay, again, KVL said that the sum of the voltage in a loop will equal to 0. And let's start from this 220 volt source, and the current here flowing from the negative terminal, so we will have negative sign. So have minus, and the value will be 220. Then we will have plus 4. Here, the current is there are two currents, IC going to the right and IA going to the left, right? But we are working on IC, so IC came first. So I'll have IC here, and then IA is flowing to the opposite direction, so I'll have minus IA. Good. Now let's move to this resistor here. So we'll have 24. Again, because we are working on IC, IC came first. But then IB is flowing to the opposite direction. IC going down, IB going up, right? So I'll have IC minus IB. And then the last component is this 2 ohm resistor. And the only loop current that passed through it is IC. Okay, so we will have all of that equal to 0. Good. Now IA only came from this place. So I will have minus 4 IA. And then IB only came from this place, so I will have minus 24 IB. And IC came from 3 places, so I will have 4 plus 24, that will be 28. And then 28 plus 2, I will have 30 here. So I'll have 30 IC. And all of that will equal to 220. Let's save this as equation number 3. Okay, now we have 3 equations and 3 variables. Okay, maybe let's clean up a bit and we need to solve it. Okay, we need to do the third step, which is to solve the equation. Solve the equation, and I think I will use the fastest way to do it, which is using calculator, right? Because in the circuit exam, usually you can bring your calculator. So why don't just use it to solve the equation? Okay, this is our calculator here. And let's set this up as equation solver, which is number 5. And we have 3 variables, IA, IB, and IC, and that is number 2. And all that we need to do is plug in all the coefficients. So I will have 18 minus 12. And then minus 4, and that will be 220. Then we will have minus 12, and then 84, and then minus 24. And then that will equal to 0. Then we will have minus 4, and then minus 24, and then 30. And all of that will equal to 220. Good, and we will have our IA value here, which is 20.906. Okay, that is not a nice number, so we just write it. IA is 20 point what? 906. Okay, 906. And the unit here will be in ampere. And what is IB here? IB, what is IB? IB is 7.6. 7.1. I think 7.20 is okay, right? So we'll have 7 point what? 620, yeah, 620 ampere. And then what is IC? IC, what is IC? IC is the Z value here. So I'll have 16.217. 16.217. And the unit will be in ampere. However, the question is not asking about IA, IB, and IC, but the branch current. So the last step that we need to do is to answer the questions. Answer the questions. Okay, let's see what the question is asking us. Okay, we have to find out I1. But then I1 is the same as IA, right? So I will have I1 is the same as IA. I1 is the same as IA, so we can just plug in the value of IA. 20.006. And the unit here will be in ampere. And then what is I2? I2 is going to the left from this component, so that will be IA minus IC. So I2 is equal to IA minus IC. And what can we do is just plug this into calculator, right? So let's do that. 20.906 minus 16.217. Okay, I will have 4.689. 4.689. Yeah. And the unit here will be in ampere. Good. Now what is I3? I3, where is I3? This one here. But that is easy, right? I3 is equal to IC. So we can just copy IC there. So I have 16.217. And the unit here will be in ampere. And then what is I4? I4 here is equal to the one that is have the same direction is IA. So I have IA. And then IB having different direction. So IA minus IB. And then that will be, okay, plug in into calculator again. So we will have this IA is this one, right? And minus IB. So I'll have 7.620. So I'll have 13.286. 13.286. And the unit here will be in ampere. And then what is I5? I5 is this going down. So the one that is going down is IC. But then IB is going up. So I will have IC minus IB. And so we will have 16.217. And then minus 7.620. Okay, and I will have 8.597. 8.597. The unit will be in ampere. And then what is I6? I6 is the same as IB. So we can just copy it, and I will have 7.620 ampere. And we have finally find out our goal here, I2 until I6. And that is the value I1 until I3 is here, and I4 until I6 is here. And I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.